Gas laws. The physical behavior of a gas can be described in terms of three variables: volume V, pressure P, and temperature T. A change in any one or more variables will result in a change in the remaining variables. The first law to be studied is Boyle's law. The volume of a given mass of a dry gas is inversely proportional to its pressure if the temperature remains constant, or V is proportional to 1 by P, where temperature and mass remains constant. By introducing a proportionality constant, the equation can be written as V is equal to K by P, or PV is equal to K constant. If the volume of a given mass of a gas be V1 under pressure P1 and V2 under pressure P2 at constant temperature, then P1 into V1 is equal to K, a constant, and P2 into V2 is equal to K. Or P1 V1 is equal to K is equal to P2 V2, or P1 V1 is equal to P2 V2. Charles' law. The volume of a given mass of a dry gas is directly proportional to the absolute temperature if the pressure remains constant, or V is proportional to T, where T is the temperature in Kelvin scale. In this case, the pressure and mass remains constant. By introducing a proportionality constant K, the equation can be written as V is equal to KT, or V by T is equal to K. If the volume of a given mass of a gas be V1 at temperature T1 and V2 at temperature T2 at constant pressure, then V1 by T1 is equal to K and V2 by T2 is equal to K, or V1 by T1 is equal to K is equal to V2 by T2, or V1 by T1 is equal to V2 by T2. Gas equation. The two laws combined can be written as: the volume of a given mass of a gas varies inversely as the pressure and directly as the absolute temperature. Therefore, V is proportional to 1 by P proportional to T, or PV by T is equal to K, or P1 V1 by T1 is equal to P2 V2 by T2. Example 1. A given mass of a gas occupies 95 centimeter cube under a pressure of 744 mm of mercury. What volume will it occupy at 760 mm pressure if the temperature remains constant? P1 is equal to 744 mm of mercury and V1 is equal to 95 centimeter cube. P2 is equal to 760 mm of mercury and V2 is unknown. Since the temperature remains constant, we use Boyle's law in the equation. P1 V1 is equal to P2 V2, or V2 is equal to P1 V1 by P2. Substituting these numbers in the equation, we get V2 is equal to 93 centimeter cube. Example 2. A given mass of a gas occupies 240 centimeter cube at 80.6 degrees Fahrenheit. What volume will it occupy at 116.6 degrees Fahrenheit if the pressure remains constant? Converting the Fahrenheit numbers to Kelvin scale, we get K is equal to F, the temperature in Fahrenheit, plus 459.4 divided by 1.8, or T1 is equal to 80.6 plus 459.4 divided by 1.8 is equal to 300 degrees Kelvin. T2 is equal to 116.6 plus 459.4 divided by 1.8 is equal to 320 degrees Kelvin. V1 is equal to 240 centimeter cube. V2 is unknown in this case. As the pressure remains constant, use the Charles law. V1 by T1 is equal to V2 by T2, or V2 is equal to V1 T2 by T1. Substituting these numbers in the equation, we get V2 is equal to 256 centimeter cube. Example 3. 475 centimeter cube of hydrogen was collected in the laboratory at 80.6 degrees centigrade and a pressure of 720 millimeter of mercury. Calculate the volume of hydrogen at STP. By STP we mean standard temperature and pressure. The standard temperature is considered to be 273 degrees Kelvin and pressure is 760 millimeter of mercury. V1 is equal to 240 centimeter cube. V2 is unknown. P1 is equal to 720 millimeter of mercury. P2 is equal to 760 millimeter. T1 is equal to 80.6 plus 459.4 divided by 1.8 is equal to 300 degrees Kelvin. T2 is equal to 273 degrees Kelvin. According to gas law, P1 V1 by T1 is equal to P2 V2 by T2, or V2 is equal to V1 into P1 by P2 into T2 by T1. Substituting these numbers in the equation, we get V2 is equal to 409.5 centimeter cube. With this, we come to the end of this lesson. For more information, you can email me at neepa@yahoo.com. Thank you and have a wonderful day.